Hey guys, welcome back to my YouTube channel. In this video, I'm going to discuss about maxima and minima of functions. Local maximum and minimum. Functions can have hills and valleys, places where they reach a minimum or maximum value. By looking at this graph, we can see where they are, but how do we define them? First, we need to choose an interval. Then, we can say that a local maximum is the point where the height of the function at A is greater than or equal to the height anywhere else in that interval. Or more briefly, f of A is greater than or equal to f of x for all x in the interval. In other words, there is no height greater than f of A. Likewise, a local minimum is a point where f of A is less than or equal to f of x for all x in the interval. The plural of maximum is maxima. The plural of minimum is minima. So maxima and minima are collectively called extrema. The global or absolute maximum and minimum. The maximum or minimum over the entire function is called an absolute or global maximum or minimum. So there is only one global maximum and global minimum, but there can be more than one local maximum or minimum. Absolute maximum is the highest value, while the absolute minimum is the lowest value. So by looking at this graph, assuming that this function continues downwards to left or right, so the global maximum is about 3.7 and the global minimum is negative infinity. So let's try to solve some examples in finding the absolute minimum and absolute maximum of a function. Example 1. Find the absolute maximum and minimum values if they exist over the given interval y equals the quantity of x plus 2 raised to the power of 3 minus 1 on the interval negative 3 and 0. So the first thing to do is to get the critical numbers. So to get the critical number, we will get the derivative of the function y equals the quantity of x plus 2 raised to the power of 3 negative 1. So its derivative is 3 times the quantity of x plus 2 raised to the power of 2. So the critical number is negative 2. So to get the value of the maximum, absolute maximum, and minimum, we will substitute the value of the intervals, the given interval, and the critical number from the original function. So for f of negative 3, we have the result of negative 2. For f of negative 2, we have the negative 1. And for f of 0, we have the 7. So now we can identify the absolute minimum and absolute maximum value. Negative 2 is the absolute minimum and 7 is the absolute maximum. So always remember that for negative integers, as the number increases, its value decreases. So negative 2 is our absolute minimum and not negative 1. So this is the graph of the function y equals the quantity of x plus 2 raised to the power of 3 negative 1 with the points, with the resulting points. Example 2. Find the absolute maximum and minimum values if they exist over the given interval g of x equals 3 over x on the interval 1 and 6. So this is the graph of the given function. So g of x equals 3 of x is continuous in the interval 1 and 6. So we're going to get the derivative of the function. So we have negative 3 over x squared. So it will never be 0. So we're going to only test the endpoints 1 and 6. So for g of 1, it equals to 3, and for g of x, it equals to 1/2. So 3 is the absolute maximum and 1/2 is the absolute minimum of the function. So this is the graph of the function with the resulting points. So that's it for our discussion about maxima and minima functions. If you have any questions, clarification, and suggestions, kindly comment it down below.